In this video, we're going to use one-sided limits to determine the limit of a function at a given value. Here, the function that we're analyzing is 1 plus cosecant of x, and we're going to analyze the limit of that function as x approaches -2 from both the left and from the right. What I went ahead and did before I hit record on this video is I went ahead and translated 1 plus cosecant of x into something that I more readily know the values of, because off the top of my head I can't really remember what cosecant comes to with very good consistent repetition, so I translated cosecant of x into its reciprocal, which is 1 over sine of x. And now I'm going to use that 1 over sine of x to kind of analyze the behavior of x as x gets closer and closer to -2 pi. What I also went ahead and did is I made a graph of the function sine of x here coming to -2 pi from the right and from the left. We have this image here. So as the x's go from -2 pi from the left, we see what our function's doing. And as it comes from the right, we're also seeing what our function's doing. So as we look at the values of sine of x as they approach -2 pi from the left and the right, we need to keep in mind that they're in the denominator of our given fraction here as a part of our function. So as we're analyzing those values of sine of x, we need to keep in mind that those are actually denominator values and not the actual values that you return that we're analyzing of our function. But let's first take a look at the behavior of our function as we approach -2 pi from the left. So what that means is we're coming towards -2 pi in this direction. This is from the left here. We see that as we get closer and closer to -2 pi, the values of our sine of x are going to still stay negative, but they're going to get closer and closer to 0. So this means that our ratio of 1 over sine x, in the case here where x approaches -2 pi from the left, is approaching -1 over 0. So our limit as x approaches -2 pi from the left will take the form of 1 minus infinity or -infinity. So that's in the case when we're approaching -2 pi from the left. Let's look at it from the other direction now, where we're approaching -2 pi from the right. We see that again, sine of x is going to be approaching 0, but in this instance we're getting a lot of positive values up here. They're getting closer and closer to 0, but we're still staying positive. So this means that in the case where it's approaching -2 pi from the right, our ratio of 1 over sine x is approaching (1 over 0). So our limit as x approaches -2 pi from the right will take the form of 1 plus infinity or positive infinity. So we see that our limit here from the left and the right, they really don't agree. So in this case, when the limit from the left and the limit from the right at the same given value don't agree, that means that our limit as x approaches -2 pi of 1 plus cosecant x does not exist. Because we want to keep in mind that even though we are talking about the values of sine of x as x approached -2 pi from the left and the right, we were looking at those and putting those values in the denominator of a fraction to return expressions or ratios that were approaching -1 over 0 and +1 over 0. So in that case, we kind of boiled down our original function into approaching forms of 1 minus infinity or 1 plus infinity to give us limits of negative infinity and positive infinity respectfully, and we know that if limits from the left and right don't agree, we get that the limit at that given value does not exist.